Hi there and welcome to another Framework GCSE Maths video where we're looking at the higher tier Edexcel Maths Paper 2, June 2019, question 18, which is a combination of understanding geometry inside a circle and circle theorems. Most students find circle theorems difficult to recognize, and I have another more detailed video just on this topic. In this question, we're asked to work out the angle ADE and are told that the lines BA and BD are equal and BC and CD are equal. And we have an angle ABD of 40 degrees. So let's look at this question from our framework approach. Step 1 tells us to label out the angle we are looking for, which in this case is ABD, ADE here. Step 2 is identify all the given facts, and we know that we have two triangles here that are both isosceles triangles because they share equal sides. And step 3 is use the known angles to calculate any unknown angles. So in our case, we've got a triangle ABD, and we're told that one of the angles is 40 degrees. The other two angles in this isosceles triangle must therefore be equal. So let's go ahead and calculate this answer. So let's label out our triangle here. So let's call this triangle 1. So triangle 1, which is ABD, is an isosceles triangle. It's an isosceles triangle, and therefore we know that the angle BAD is equal to the angle BDA. To calculate that, we need to work out the total number of angles in a triangle is 180 degrees minus the angle given here, which is 40, divided by 2, because these angles here and here are equal angles, and that gives us 70 degrees. So that's 70 there, and that's 70 degrees there. The next step is to look at triangle 2, which is here, which is BCD. Now in this case, we need to work out what this angle here is, but there's no easy way of working that out because in fact there's no angles are actually given to us. And the reason why we want to work out this angle is because angle ADE sits on a straight line. So if we can work out the total angles across this point here, then we can easily work out ADE. So because there are no easy angles in this particular triangle BCD, we're going to have to start thinking about our circle theorems and what we know, or what circle theorems could we utilize to calculate that would help us calculate the angles in this triangle here. In my more detailed video about circle theorems, we go through an elimination process to understand which is the appropriate circle theorem to use by asking ourselves where the lines actually cross in the circle. But to save time, I'm jumping ahead, and in this case we have 4 lines AB, that's lines AB to BC to CD to AD that form what is known as a cyclical quadrilateral. Quadrilateral meaning a 4-sided shape, and a cyclic meaning it exists within a circle. And there's a cyclic quadrilateral circle theorem that you need to know about, where the opposite sides of the opposite angles in a quadrilateral add up to 180 degrees. So A plus C adds up to 180 degrees, and B plus D adds up to 180 degrees. If we go back to our question here, we can see that we've got an angle BAD is 70 degrees, which means that the angle BCD must be 70 plus some number to give me 180 degrees. So let's go and work this out. Now that we've identified that the 4-sided shape ABCD is a cyclic quadrilateral, let's just try and label up our information for the examiner. So point 1 here was that we understood that triangle 1 was an isosceles triangle. Triangle 2 was also another isosceles triangle. And the third point was that we've identified a cyclic quadrilateral, which is A, B, C, and D. And we know that angle ABAD is equal to 70 degrees. Therefore, angle BCD must be equal to 180 degrees, because we know that opposite sides of a cyclic quadrilateral add up to 180 degrees. So this is 180 degrees minus 70 gives us 110 degrees. So we now know that this top angle here is 110 degrees. So we now have a missing piece of information about our triangle 2, BCD, as an isosceles triangle. Given that we know that this is 110 degrees, we can go ahead and work out these two angles, BCD and CDB. So we can say that BCD is an isosceles triangle, which we said earlier on, and we can therefore say that angle CBD is equal to angle CDB, which is therefore equal to 110 degrees minus 180 degrees. I'll just recorrect that. 180 degrees. So 180 degrees minus 110 degrees divided by 2, because we've got two equal sides angles here. That gives me 70 degrees over divided by 2. That gives me 35 degrees. So our missing angle here is 35 degrees. Now we were remembering we were asked to calculate angle ADE. So from the missing information the information that we calculated out from these two angles, we can say that angle ADE is equal to 180 degrees, because we're talking about a straight line now, minus 70 degrees from here, minus 35 degrees from here, gives us 75 degrees as this angle here. And that's our answer. Angle ADE is equal to 75 degrees. So let's do a quick summary of all the steps we took to solve this problem, which was to solve angle ADE. We found out that that was 75 degrees. The first thing we did was we labelled all our known sides and angles that were given to us in the question. We identified that there were two isosceles triangles and a straight line here. And we also later on identified that there was a cyclic quadrilateral as a circle theorem that existed within this circle. We calculated the apex, the base of the first isosceles triangle ABD, by taking 180 degrees away from the apex angle, 40, and dividing it by 2. And we know in an isosceles triangle, the apex angle plus the two base angles equal 180 degrees. Using the circle theorem for cyclic quadrilaterals, we know that the opposite sides of the quadrilateral add up to 180 degrees. That allowed us to work out that the angle BCD was equal to 110. So 110 plus 70 gives us 180. And that then allowed us to work out the base angles from the second isosceles triangle to here, where we did 180 minus 110 divided by 2 gave us these two angles here, 35 degrees. Knowing that this is a straight line, the line EDC, we could then work out from 180 degrees, take away the separate angles we worked out from the two triangles to finally get our answer ADE of 75 degrees. I hope you found that useful.